All right, so welcome to my TED Talk on how to name simple hydrocarbons. The first thing we need to address is what the heck is a hydrocarbon. So if you look at the formula C4H10 and you were going to name it using the prefix system, well, 4 is tetra, so you call that tetracarbon. 10 is deca, so you call that decahydride. Tetracarbon decahydride. The problem with that name is it doesn't tell us anything about that molecule itself. What we see is there are actually multiple ways to draw this. One of the simplest ways to draw this is just put all the carbons in a straight chain and put all the hydrogens around that. But a less simple way to draw this is to put all the carbons kind of in like a 3-ring circus sort of looking thing and then put the hydrogens around there. And as it turns out, these two molecules have very, very different properties. The top one is a gas at room temperature. The bottom one is a liquid at room temperature. The top one burns very readily. The bottom one burns and tends to produce an excess of carbon. Very, very different molecules here. The same thing could be done with C4H8, which is another perfectly acceptable molecule. Tetracarbon octahydride is what we would call that thing right there. And there are lots of different ways to draw this one, but two of the biggest ones are the one up top here, where all the carbons kind of link together in a circle, and then down here at the bottom, which is really hard to see with my face in the way, but down here at the bottom we can put them in a chain. And again we see here, this top one, super unstable, very explosive chemical, very reactive chemical. The one at the bottom, fairly non-reactive. You find it in gasoline, but it can also be used to, say, example, remove too much bromine from pools or too much chlorine from pools. So both of these molecules, very, very different, and the formula just doesn't tell us enough about them. So chemists discovered this a long time ago, that we needed some new way to name these molecules rather than the prefix system. And so what we do is we use a new hydrocarbon naming system to name these things. And what we do is we look at them. Any hydrocarbon, just to give you the explanation there, is a chemical that's made up only of carbon and hydrogen. They were named because originally it was assumed that hydrogen was the important part, but as it turns out, they're not. The important part here is the carbon, but the name has just stuck throughout the millennia here. Not millennia, throughout the centuries, since we named them this. There are basically 3 different kinds of hydrocarbons. There are alkanes, which have this formula right here, where you have a number of carbons, and then you have twice that number of carbons plus 2 for the number of hydrogens. So, for example, if you had 2 carbons here, you would have 2 times 2 plus 2, or 6 hydrogens. C2H6 would be the formula for an alkane. There are alkenes, where you have the number of carbons doubled, and that gives you the number of hydrogens. So, for example, using our C2 example, it would be C2H4, right? Because that would be twice the number of carbons in hydrogen. And then there are alkynes. We have alkanes, alkenes, and alkynes. And it turns out alkynes have twice the number of hydrogens as carbons minus 2, right? So if you had 2 carbons, 2 times 2 is 4, minus 2 is 2. You'd have 2 carbons and 2 hydrogens. Not always the same number, so to throw in another one there to make sure you don't make that mistake. If I had 8 carbons, then I would need 16, 2 times 8 is 16, minus 2, or 14 hydrogens. So it would be C8H14 for an alkyne. And all these have very different properties. Alkanes tend to have that kind of gasoline-ish smell. Alkenes kind of have a fruity odor to them. And alkynes have this heavy, oily chemical smell to them. This is very, very unique. All three of them, different properties, different reactions that they have. And this is just one way we use to distinguish these hydrocarbons. So, how do you get the formula of an alkane that has 10 carbons? And this is the steps that you would go through. So, for example, we have C10. Okay, that's 10 carbons, which means that N equals 10. So, for the number of hydrogens, you would take 2 times N plus 2, or 2 times 10 plus 2 is 22. So that would be the number of hydrogens you have, and so the formula there would be C10H22. And how do we name them? I'm not going to ask you to name C10, but what we do is we have a prefix, and then depending on the formula, we add ane, ene, or ine to the end. And we are going to practice this a whole bunch tomorrow, but I want to throw a few of these prefixes at you. There are only 6 that I want you to memorize. And the first prefix is for one carbon, that is meth. And everybody's heard of meth. You're like, crystal meth? Crystal meth gets its name from the fact that it is methamphetamine, which gets its name from the fact that they take amphetamine and they remove something off of it and add one carbon in there. So literally the name methamphetamine means one carbon substituted amphetamine. And that is where one carbon is meth. 2 carbons is eth, and the ever so common ethanol that you find all over, which is known as drinking alcohol. 3 carbons is prop, as in propane, right? Propane gas has 3 carbons per molecule. And then 4 carbons is bute, not but, it's pronounced bute. And you've all heard of, I'm sure, butane, as in a butane lighter. This is used, you can compress it into a liquid at a fairly close to room temperature, and then they put it inside the lighter. But whenever you open the lighter, it comes out as a gas. And then 5th is the one everybody's heard of, it's pent, right? 5 carbons is pent. 6 carbons is hex. You can probably guess what the rest of them are just from that. But those are the 6 I expect you to know. Meth, eth, prop, bute, pent, and hex. And yes, tomorrow we will definitely be practicing these en masse.